like my favorite class.
Really? Some of the class said all day that they didn't work.
What's with you?
It's not gonna be sad.
It really is.
Makes me wanna like.
This is the only class I work
Face.
Like,
I don't do any work.
okay, but this is the only class that we work all the way through.
Really?
Most of them will give us like a 10-minute assignment session.
I did, but I was looking.
We had this one.
What?
I have English board and then I have my 7th grade class like 3.5 hours.
Let's say difference of squares.
Okay, write these special types of factoring down and leave some space between them for a generic pattern. First one we got is difference of squares. Underneath that is perfect square trinomial. And the last two are sum of cubes and difference of cubes. We're going to leave some space to put the special patterns that we got with them. Notice there is no sum of squares. There's no such thing. People try to factor with sum of squares every year. It does not work. There is no sum of squares. So what was?
How much space?
One line. That's okay.
No, we got to redo that.
Oh, wow. We're just going to put one example for each of them. Well, I'll tell you, on perfect square trinomials, we're going to put 2 examples. So not 1, 2.
That's what you did.
Takes me like 5 pages to do notes. Because I write so big and sloppy. I write so sloppy and I write so big. But I found all the notes that I taken to the classroom. So first has been in here for 2 years.
Yeah. The only time we did it was when she wasn't. Which was like 3 days.
That's really the only time we ever do work. I think you give us like 1 every.
Oh my gosh.
You know, sign it?
Yeah,
Really?
Yeah, that's what we did a lot. And she was like,
Oh yeah, she always got that.
so she was like, again, hunting and we did. We'd skip her class like every Friday to go home. Go at her 7th grade.
Alright, difference of squares. There's the pattern. We've used this since junior high, middle school, so you ought to have it down pretty good by now. If I have a perfect square minus another perfect squared, I'm told to factor. All you do is take the square root of them. One of them gets a plus sign, one of them gets a minus sign. Okay? Perfect square minus perfect square. Square root them into 2 parentheses. One gets a plus sign, one gets a minus sign. Now, every time we do that, someone will say, well, where do the middle ones go? Because how you would check it would be to FOIL. If I do that here on my outer, that gets me a negative AB. On my inner, that's a positive AB. Positive and a negative cancel out. That's why there's no middle term in that one. Okay?
I have a question.
Yes?
How's that?
Shh. Gravity.
Yeah, gravity goes down. That's what she's asking.
No, but the alligator has gravity. He has his own gravitational.
Annabelle, please go to the high school office to check out.
Alright, perfect square trinomial. Okay, perfect square trinomial. We're going to have 2 patterns that we're going to write in that one. If I've got, we'll use A's and B's still, A squared plus 2AB plus B squared, that's the same as A plus B twice. Okay, then I could also have, she'll be quiet, I could also have it with the minus sign, A squared minus 2AB plus B squared is A minus B. I'm moving mine twice. Now to be a perfect square trinomial, notice in both of those patterns that we wrote down, the last sign's a plus. A squared, whatever, AB plus B squared. That has to be a plus in the second spot.
Is that the ticket?
Yeah. Alright, then the last two, the sum or difference of cubes. You're not told to factor with cubes near as often, so you don't use that as much, which means it's more likely forgotten. Algebra 2 people's bell ringers today was a sum of cubes factor, and they act like we've never done it before, even though we did it last week. Silly wabbits. But sum of cubes, if you have a perfect cube plus a perfect cube, factors as the cube root. I'll scoot it up a second. And the difference, just the signs are different. Alright, get those last ones down, then we're just going to jump in and work some problems.
Okay. It's starting to feel good in here.
It's been burning up all day.
First one's the word first. It's always hot.
It's supposed to be 80 degrees tomorrow.
Oh my god.
Is it really?
Yeah, tomorrow Friday. We go from cold on Tuesday, Wednesday to
Holds out.
warm on Thursday.
I ain't talking about Colorado.
Yeah, me too. I'm moving to Colorado. Colorado's awesome next week.
Yeah, there's some snow in there later.
It'll be 90 and then snow the next day and it'll stick and we'll have a big old snowstorm and then we'll have the hottest December of 100. Oh yeah, and then we get flooded at the end of December. I go heat,
I love
whatever you call it.
I'll
Anyway,
hopefully have a snowy December.
We're supposed to.
we're supposed to have a really snowy winter.
I'll believe it.
It's showing right now.
Yeah, it's really showing.
Like our fire's supposed to be good at football this year. Don't act like we can.
It's meant to be bad.
Nobody.
They're still undefeated.
Okay.
No, I just keep my foot down and your legs are all the way over here. You're so long.
I'm sorry. With this mom suck, I don't care.
You're like,
Boys,
talking about your
Oh, man,
legs.
what I hate that.
I should not be keeping your feet. You should not be going over here.
Unless you football.
Okay, we're going to do these three to start with, sticking with difference of squares in the beginning. I got a couple more difference of square ones we're going to look at, but these are the three easiest ones, so I got those on the same page together. Number one up there says p squared minus 100. First rule is still got to be checked for a GCF. So before you get too far gone in that, p squared minus 100, does that have a greatest common factor? Right, other than one, danger out, there's not anything. So I can't factor anything out of that. So now I notice it's a binomial. Two terms, it's a binomial. So I'm checking to see if they're both perfect squares. Is p squared a perfect square?
Is what?
Is p squared a perfect square?
Yes.
Yes. Is 100 a perfect square?
Yes.
Yes. Is it a minus sign?
Yes.
Yes. So check, check, check. They're all good for difference of squares. So we take the square root of p squared, the square root of 100. One gets a plus, one gets a minus. That's it. Does it matter if the plus or the minus goes first?
No.
Nope. Put them in either order you want.
Without one.
Easy schmeezy. Okay, on number 2, 2x squared minus 18. If you forget a step on number 2, you're going to struggle. What's the first step?
Greatest common
Good, greatest common factor. What is the greatest common factor of 2x squared minus 18? Good, so we're going to take a 2 out of that. Okay, now that binomial that we have left in the parentheses, you should be checking to see if it's a difference of squares.
Yes, it's
Yeah,
perfect.
because 18 divided by 2. Yeah. Perfect square? Yep. Perfect square? Yep. Minus sign? Yep. So we got the 2. Square root of x squared is x. Square root of 9 is 3. That's it. That's all. That's all. Good.
Yeah, I made the best
Zane, did you say the D word?
That's what they all say.
Mm-hmm.
Even the teacher.
Yeah.
Okay, that's fine.
Alright, number 3. 9a squared minus 16b squared. What's different on number 3 is I added an additional variable. We got a and b both on number 3. Is there a GCF on 9 and 16?
3.
No.
Nope, 3 won't go into 16. Good thought though. So there's no GCF other than 1. Is 9a squared a perfect square?
Yeah.
If it is, tell me what the square root of it is.
3A.
3a. Is 16b squared a perfect square?
Yeah.
Yes, what is it?
4B.
4b. So this is just a difference of squares.
Yeah.
3a plus 4b and 3a minus 4b. That's it. Nothing to it. Remember that from since middle school, right?
Oh, yeah.
Alright, a couple of more difference of squares. There's your hint, but they're a little bit tougher. I got m plus 3 squared minus 49z squared. Alright, we did one similar to this in... I'm sorry, got it back in the back. Did you get it off, Michael? Okay, I'm sorry. Tolerate me if I ever need to go back.
Yeah, you need to go back now.
Not now, but you got it off Michael.
Good.
Yeah, I'm caught up now.
I hope it did.
I want you to get off the board too?
I put it on pause just for you to plug it. No, you don't have it already have that.
Why are you writing so slow?
It's gotta be neat.
Okay. Alright, we did something similar to this in class yesterday. What's different is that instead of just an m squared here, I've thrown a whole binomial. So I've got this whole thing squared. This is still a difference of squares because this whole piece is a perfect square since it's being squared. And this is a perfect square because the square root of that's 7z. So yesterday we plugged in a substitute variable. I could do that again here, but this one's not as complicated. I'm just going to keep it like it is. I know I'm going to have something plus something and something minus something. I already told you what the square, you already know what the square root of 49z squared is, so you can put your 7z's in there. My orientation's a little off. Anyway, what's the square root of m plus 3 squared?
M plus 3.
Good. So you just got an m plus 3. That's it. Let me orient and write.
Hang on.
What? Okay, I was going to try to write it neater, but I'll orient after Caleb's finished interpreting my hieroglyphics.
You just messed
Really
up.
demanding.
I'm slow.
Got it.
Okay, you're good now. Sorry. I'll just go back home. I didn't want to hear anyway.
That voice is funny. Sounds like a guitar.
There you go. That's a little bit easier to read. All right. We all right? Okay. One more difference of squares here. Y to the fourth. This is probably my favorite difference of squares problem. Y to the fourth minus 16. If y to the fourth is a perfect square, then what's its square root?
Y squared.
Y squared. Everybody all right on that? Very good. Okay. Y to the fourth can be y squared times y squared, right? So I know I'm going to be looking here. Y squared plus something and y squared minus something. Now you better already know what the something is.
Yeah.
What's the square root of 16?
14. 12?
Okay. Now,
32.
in all the problems that we've done so far, we were done there. Zip, you're out, circle it, it's finished. Not here. There is one of those binomials, not both of them, one of those binomials that you can factor farther. Would it be door number 1 or door number 2?
2.
2. Why door number 2?
Differences.
It's another difference of squares. Perfect square,
Oh, I see
perfect
now.
square, minus sign. Remember I told you there's no such thing as sum of squares factoring, so that first door stays how it is. So I'm just going to drop it down. Y squared plus 4 Now this one be a y plus a 2 and a y minus a 2. That's it. Where weren't you there?
No, I'm gonna print out.
Oh my goodness, what's my soul? There is on the other roll.
You said that too fast. Yeah. Is that a problem?
Make sure we were on the same page. Wait for the end of the table in that class. It's weird.
That one would have hurt.
It's weird. Hey, when you start damaging the school property, we have a problem. Hey, Hayden. Yes.
I hate to ask so many notes.
I know, I hate for you to have any notes, but I'm assuming
That's
it's
why I
an
was
emergency.
hesitant on the handbrakes. I always leave that here.
Thanks.
You can copy off my notes whenever you get back.
Give it. Give it.
Alright, check it out. I got 49z squared minus 14z plus 1. We've obviously changed gears from the last problem because this one's a trinomial. Previous problems were mostly binomials. Now we've got a trinomial. So, we could factor this the way we did yesterday. You could do a times c, which would be 49. The factors of 49 that added negative 14 are negative 7 and negative 7. Plug them in and factor by grouping. We did that all period yesterday. That would work here. There is an easier way, though, when it's a special, when it's a perfect square trinomial. So I'm going to do it using the perfect square trinomial. And here's what you got to check for. Is your first term a perfect square?
Yes.
Yes, 7z, right? Is your last term a perfect square?
Yes.
Yes, 1. The product of those, Caitlin, 7z times 1, is it half of the middle?
Yes.
7z is half of 14z, right? So that means it's a perfect square trinomial, which means I can factor it that way. You wrote this note down. Square root, minus sign, minus sign. That's it. Remember I told you a perfect square trinomial, the last sign always had to be a plus, so the sign in your parentheses will be whatever the first sign is. Now if you didn't remember that, it's not the end of the world. You would do your a times c, you'd factor by grouping, and you would get 7z minus 1 twice. You would get the same thing, so it's not bad if you forget. But that's just a lot quicker if you're doing something on ACT, you got to save some time, whatever. Also, remember you got the choices on our multiple choice test. When you got time, you can FOIL them and work your way backwards. You can do that on the ACT too, but you don't have as much time on the ACT.
On the ACT, you only have 3 hours.
60 minutes, 60 questions. You got to book it for the math.
Unless you cheat.
Yeah, I did it. Here. You made it 16.
Right, I got 9a squared plus 48ab plus 64b squared. Now this one would be one where it would be more difficult to factor by grouping. Number one, I don't know what 9 times 64 is, so I would be using my calculator on that. So I'm going to check and see if I can do a perfect square trinomial. Okay, so first off, let's not forget, what do we need to check for before I do anything? Factoring, what do you always got to check for? CF. Okay, do you got one?
Maybe.
You don't. I got on a tangent with first period. I'm not going to go completely nuts with y'all on it. In middle school, y'all did divisibility rules.
Yeah.
Okay, I can look at this right here because I wanted to say 3 for a GCF. Okay, so 3 goes into 9 evenly. Does 3 go into 48 evenly? Divisibility rules say if the sum of these digits is divisible by 3, then that number is divisible by 3. 4 plus 8 is 12. 12 is divisible by 3, right? So that number is divisible by 3. 6 plus 4 is 10. 10 is not divisible by 3, so my 3 idea was out. You remember those from middle school?
No.
Ooh, those were good. That's stuff you need to be able to use. But anyway, maybe we'll have time one day to talk about those. All right. So there's no GCF. Is it a perfect square trinomial? Is this a perfect square?
Yes.
Yeah, 3A. Is this a perfect square?
Don't know.
Yes.
8B. Good, Aaron. 3 times 8 is 24. Is that half of this?
Yes.
Yes. So it's a perfect square trinomial. So square root. This sign's plus. Take it twice. Bam.
Boom, that's easy.
How can I check that if I wanted to?
You can do the foil thing.
Write it twice and fold it. Y'all got it. Y'all smarter than the average bear, as Yogi would say.
I look like a Bigfoot.
I shot this albino polar bear one time.
He has an albino squirrel that we killed.
Okay, this problem, this is combining perfect square trinomial and difference of squares. We're fixing to do them both right here. Perfect square trinomial and a difference of squares. Okay, it's got 4 terms. Number 1, that's something to clue you in that we're going to do more than what we've been doing. Is there a GCF in all 4 of the terms?
Would it? Nope.
Nope, not other than 1, you're right. So what I want you to zone in on now is that.
Yeah.
Just the first 3 terms.
24.
Let's look at it as a trinomial. Is that a perfect square trinomial?
Yes.
Is x squared a perfect square?
Yes.
Is 1 a perfect square?
Yes.
Is 1x half of 2x?
Yes.
So this is the same as x minus 1 squared, right? And then I still got a minus y squared. Do you see that as a difference of squares yet? Perfect square minus perfect square. So we know it goes, difference of squares goes like this. Square root of the first one. Square root of the last one. Can I simplify those parentheses, like combine like terms? There's no like terms in there, is there? So that's it. You don't have those types of factoring problems often. Those are considered the higher level ones, but it's not that hard. It's just you don't do them as often to get as much practice on them. I think it's kind of cool.
Me too.
Alright, we did different squares, we did perfect square trinomials, cubes. This is the last one. We ready for cubes? Say what, Willis?
Did everybody speak Spanish right now?
Oh, albino. I thought you said Albanian. Yes. I mean, why can't I wait till you're done?
Never mind.
So, next time I start putting that big N word, Mason.
No.
Alright.
You can tell Pocket now. Yeah, I don't know. We're getting close to being done. We have one more.
Alright, we got x cubed minus 1,000. Told you we shifted gears. First clue here that we might be doing a cubes is it's x cubed. Oh, that was deep, right?
Yeah.
We got x cubed. There's a minus sign. That's difference word, isn't it? So if that 1,000 is also a perfect cube, we're looking at difference of cubes. Is 1,000 a perfect cube?
Yes.
Yes. So what is the cube root of 1,000?
10.
10. Now we're going to do some where it's not as obvious. So if you don't remember how to find cube root, hit math. I think it's number 4. It's got the 3 in the radical, so it does the cube root for you. All right. Difference of cubes formula. We got to know our A and our B. Our A is the cube root of the first term. So that's x, right? Our B is the cube root of the last term. Y'all just said it was 10. So now all we're doing is plugging that in the difference of cubes formula. It says A minus B. That's your first parentheses. Second parentheses is A squared plus A times B. Oh, don't close that yet, stupid. Plus B squared. 10 squared is 100. And that's it. You're done. Sum and difference of cubes are quick to factor But again, that's one that's not used as common, so you forget about it a lot. A lot of people will look at this trinomial and think it'll factor farther. I remember I did that originally also, but it never will. Okay, here you can look at this, do your A times C. Factors of 100, you could be 1 and 100, you could be 2 and 50, you could be 4 and 25, you could be 5 and 20, 6, 7, 8, 9, you could be 10 and 10. None of these pairs add to 10. This is 101, Caitlin, this is 52, this is 29, that's 25, that's 20. None of them add to 10. Won't factor any farther. It's that way every time in sum or difference of cubes. When you get a binomial and a trinomial, you're kaput.
You wrote it wrong.
I did.
Because you put
I put a B instead
you
of
put
an X.
10B, so it'd be like yeah.
Thank you, Caleb. My B and my A. There we go. So I kind of had my B trying to put it in there twice. Whew. All right, we all right on that? Got another couple of those.
Good.
It would have worked if you would have kept doing that.
I mean, crazy. Yeah, 10 and 10. All right. So if we have
Door.
8p cubed plus 125. 8p cubed plus 125. There's only two terms, so it can't be a perfect square trinomial if there's only two terms. I know it's got to be a trinomial one.
Can I take some pictures?
Yeah, don't take pictures of people that aren't doing what they're supposed to be doing, though. I don't like to publicize that. Get pictures of studious people. All right, 8p cubed plus...
No, don't.
8p cubed plus 125. We're checking... Zane, pay attention. We're checking to see if it's a perfect cube or not, since this is a cube. Is 8 a perfect cube?
Wait, hold on, sorry.
Is 8 a perfect cube?
Yes.
Yes, 2, right?
Yeah.
So if this is a sum of cubes, my A is going to be 2p. Is 125 a perfect cube? Something times itself 3 times, get us 125.
Yeah.
Yes, it does. What?
5.
Thank you, ma'am.
Oh, thank
So my B is 5. So it is a perfect, it is a sum, because we got a plus sign. It is a sum of cubes, right? So look at your sum of cubes formula. It says A plus B. So there's your first parentheses. Now be super careful on the second parentheses. Second parentheses says A squared. Our A is 2p. So we have to square that whole thing, which makes that be 4p squared, right? You got to square the 2 and the p. So we got 4p squared. A times B is our second thing, so 2p times 5. Forgot my sign for a minute. And then B squared, so 5 squared. And that's it.
Sweet.
Sweet. I got one more. Can you handle one more? Yes, you can.
Sure can.
Alright. Says 64 m cubed plus 125 n cubed. Alright, so you ought to be thinking sum, because it's a plus sign, of cubes, because both your variables are cubed. But then you got these numbers there. You got to figure out if those coefficients are perfect cubes. So does some whole number times itself 3 times equal 64?
Is it 4?
Yes. Yeah, 4.
Get it?
Is that too fast?
Well, you still need to practice for the test. Hit math. And I think it's number 4 that's got a cube root. Is that right?
That's way
But I heard something.
4.
Hey, calm down out there.
Class. Alright.
F
Yeah, and then type 64 in there. There you go. So that's how you can check any of them. Chase, stop. Alright, so we got
We're golden.
an A
Wanna see what I mean?
of 4
I
M.
think you're Untitled.
Shh. Okay, we all right on that? And we already used 125 earlier, so you should have known that was a perfect cube. Our B is 5 M. Okay, it's a plus sign, so make sure you use the sum pattern because the signs are different. A plus B. There's your first parentheses. Now remember, when we square this stuff in our second parentheses, you have to square the coefficient and the variable. So A squared would be 16M squared, right? 16M squared minus A times B. What's 4M times 5N?
20 M.
Thank you, sir. Plus B squared. Square the 5 and the N.
25 M squared.
5 N squared.
That's it.
That's it. And I always get tickled. People say, well, it looked so much simpler in the beginning. It should when you're factoring. My analogy of factoring is we've dragged our bicycle into the garage. We had a complete whole bicycle. Here's your complete whole bicycle. We took it apart, every part, and laid them out on the garage floor. Here's all your bicycle parts. So the factors, there's a lot more factors than the one whole. So it always should be more factors.
Good analogy.
Thank you. Thank you. Alright, so next stuff coming up tomorrow is just still more factoring. This is a pretty good whole big unit on factoring. What we get to towards the end of it is using factoring to actually solve equations. Okay, so that's where we're going with. Good stuff. Good stuff.
Ask you a question.
I don't remember. Let me check and see. I think we did. Let me check and see.